in factoring. Now I brought this up, or organized it as, first, there might be, and I'm going to use initials here, in factoring, there might be something called a greatest common factor. Now this goes way back. So that means if, a little bit later, I should see something like this for a greatest common factor. 3x plus 6. This is 3x plus 6. Can I now factor that? I can if I recognize there's a common factor of 3, that I could do this to it, take out the 3 by dividing, and quickly call this x plus, and 6 divided by 3, guys, is 2, and there it is in factored form. Now that's way back in Algebra 1. They teach Algebra 1 now, 5th grade. That's going way back. Is that true? Just searching for a common factor, you take it out and you're finished. Now could I have some of those types on the quiz next week? Of course I could. See if you recognize a common factor. Number 2, I brought in also one like this. 5x squared, subtract 4x. Can I factor this one? Is there a common factor I can take out like I did the 3 on the previous problem? Guys, what can I take out here? Do they share something that I could pull out as a common factor? X. So if I take x out, be careful, please tell me, will I end up with 5x subtract 4 remaining? If I divide both those terms by x. Now, a quick check to see if you're correct. You use something called the distributive property. If I check this by using the distributive property, distribute the x, that'll take me right back to this. That checks. So that's a common factor. Part B. A few things to say before we jump into that handout about factoring. Yes, if I see this and can recognize a difference of squares. A difference of squares. If I see it, I can recognize it, can I deal with it? An example. One of the most basic examples is this. Can I factor x squared subtract 25? I see it's a difference, I see a subtraction sign. So there's difference. Now squares, of course, you're squaring x here to get x squared. Here, nice, you're squaring 5 to get 25. Now what does that factor into right quickly? Into x subtract 5 times x plus 5. And there it is, factored, and you can check this by using something called FOIL. Some of you guys use the word FOIL, or distributive property, and it checks. Another example of a difference of squares, if I recognize it is a difference of squares, one of the easiest factoring to do is this one. 49 y squared subtract 1. Guys, you'll see it's a subtraction sign there, indicates a difference. Now, are those squares? Are the first term and the second term recognized as squares? Guys, what squared would give me 49y squared? 7y. Thank goodness on the end here, easily seen, 1 squared. 1 times 1 is 1. I have what is called a difference of squares. If I do, easily done, always. I'll take 7y subtract 1, 7y plus 1, and I'm finished. Difference of squares. One more, number 3 here, since I'm talking about difference of squares before I move on. If I solve this, oh yeah, this was a nice one here. 16x squared plus 4. Can I treat this as a difference of squares? Cannot. What's wrong with it? Why should it not be in this category? I see a plus sign. I don't see a minus, so I can't use this little process called difference of squares. That's where some students mess up, so I'll jump into it. Do I still have squares though? I think I do, because right here I think this is like what? 4x times 4x squared. And my last term is like what? 2 squared. I still got squares, but it's not a difference. So I can't treat it like this. It doesn't fit the category. Now, can I do something else with it, though, if I'm desperate? Can I factor some other way? Yeah, I'll go back to number 1. Is there a GCF? Can I go ahead and take out a greatest common factor and write this as, and by the way, what is understood to be my greatest common factor? 4. Take that 4 out, like I was doing in part 1 of there. 16 divided by 4 out front is 4, so it's 4x squared plus, and on the end, 4 divided by 4 is 1. At least I can do that. It's so tempting to think, Professor, you mean you can't do anything else with that 4x squared plus 1? No, because it's not a 4x squared minus 1. It doesn't fit the category of a difference of squares. I can't do anything with a sum of squares. There's no category for it. Okay, letter C. Leading you all into this handout here shortly. Looks like this. Beautiful. X squared, subtract x, subtract 6. Three terms. And I don't know whether anyone can recall the name for an expression that has 3 terms. In this case, we have a trinomial. Now, does anyone recall, how can I factor a trinomial? It's not a difference of squares. It's not that category. And I don't see a common factor among those 3 terms. Does anyone recall, what can I do to use this word factor this way? Or is it possible? May not be possible. Does anyone recall how to factor a trinomial? Not difference of squares. I don't see a common factor. Are we stuck? We can't factor this?
2 factors.
Okay, 2, she's telling me now, Professor, I sort of recall, this one can be broken up into 2 sets of parentheses, and then we sort of fill in. Some textbooks will call it the trial and error. Guys, to get the x squared, I have an x times x to get the x squared. Now in the end, I need a -6. Possibilities, I could put a -6 here and a +1 there. Or a +3, -2. Or backwards, -2, +3 to get the -6. Now, which choice should I use? Now, if I use, I'm gonna try one here, guys. Suppose I use +3, -2 for the last 2 terms, and that product, 3 times -2, is this. It's -6. But the catch here is, will these, when I take a closer look, this is a -2x, this is a 3x. Guys, if we put those like terms together, what is 3x and a -2x put together if I've arranged these correctly? If I put those like terms together, do I get what, 1x? What did I really want to come out? The way this looks, I wanted a -1x to come out. That's where you check this. So what might you want to do to make a little change so maybe the -1x will come out, not the positive? What can I do?
X minus 3.
X minus 3 and x plus 2. That's going to now change this into that. And then put them together, you get your -1x that you were seeking for that middle term. And it factors. Okay? And some students may see a quicker way to do these. Letter C, seems like I had something else to say before I leave that one. Maybe I had another example. I had another example. Next example here, number 2. Another little trinomial here that I brought in. Let me see if it looks nice. It does look nice. 2x squared plus 5x subtract 12. I'd like to just merely try to factor that. Another trinomial I want to factor. I'm going to try the method suggested to us by a student. Professor, try 2 sets of parentheses and start filling in. And check and check and check until you finally have the order that you have. Now some of these may not factor. I'm going to try this one. For the first term, 2x squared, I think all of us would try maybe 2x and x. That's 2x squared. Now in the end, I got -12. I'm looking at the last term. Possibilities for a -12, and I don't know what's going to work myself yet. Could be a -4, +3. +3, -4. +6, -2. -2, +6. 1, -12.
-10.
Now, of all those choices, until you try something, lots of possibilities for -12. What should I try? We'll check and see, like we checked this one, to see which possibility will work. And the sad thing is, maybe nothing works. Let's hope something does work. Who has an idea? What are you gonna place here? You gonna put 4 and 3, 6 and 2, 1 and 12? It's up to you. And then we'll check it. Who has an idea? And we'll try it. Let's see if it checks. Who knows? You may be lucky enough on the very first choice. It may work. Any choices? And who knows? Ramsey may have brought one in that will not factor. What do you think? Yes.
+2 and -4.
+3 here, and a -4 here. Well, 3 times a -4 is -12. Now though, the important part to check and see if that choice is correct, or must I go back and change it to maybe 6 and 2? I don't know yet. Guys, I'm looking at these. Little check here, and these, always. This much is a -8x for a product. Here's 3x for a product. Combine those like terms. If you put 3x and a -8x together, what do you get? -5x. That's what you wanted. So with his, with your help there, it worked out. Is that true? Did it give us what we wanted or not? Look at it closely. Did it give us what we wanted? Not quite. What's wrong? I think I'm gonna get what, -5x? And what did I really want? +5x. So I may have to make just a minor adjustment and say, well, hold on, Professor, you're awfully close here. Maybe this should be the negative, and this should be the positive. And now you're looking at this, Professor, on these +8x, and up here -3x. Now, with those two put together, give me 5x. There's that little adjustment. Okay, so at least we got to start with the start that was given to me, then we had to make a little adjustment, there it is factored. Done. Now, have I seen some of these where you sit there maybe half an hour trying to factor, and they give you one that will not factor? So you're not guaranteed all these will factor. So far, mine have factored. So that's another type, guys, we can run into. Trinomials could be more than 3 terms later on, but right now 3 terms. Letter D. Now this one I don't think, but we'll see. I don't think on the first try, I don't think I've had a student in all my classes to get this one. Let's see how this class does. You saw this. This is, I will tell you ahead of time, the hardest one to factor. And I will tell you ahead of time, it will factor. X cubed subtract 8. A student may reflect back and say, oh, I think I sort of remember way back, Professor, how it might work. Now, before we start thinking about it, please, if this had been this, now I'll come back to it. X squared subtract 16, then you're back into a difference of squares. That one's done easily. X subtract 4, X plus 4. We discussed that. No, I gave X cubed, and I think this was an 8. Different story altogether. Now, would I be pleased if the very first day you met the class, that someone gets this one? Anna, I know you remember how to factor this. Just in case you run into it in a Math 7 a calc class, and all of a sudden you're doing calculus, but they expect you to factor this x cubed minus 8 before you do the calculus. Does anyone recall? It's a little tricky. Hardest one so far. Yes?
Add 8 first? And
Okay, Peter, tell me more.
okay, and then after that, you cube root both sides?
Okay. If this were an equation, I would maybe take your suggestion. Move the 8 over. I don't have an equals.
No equal?
No equals, just factor. So another hand going up, I thought.
I don't really know how to read it, but it's like x minus 2 times x minus 2 times x.
Ooh, you're getting close, getting close. Okay, he says x minus 2, Professor, times x minus 2, Professor, times another x minus 2. I will tell him ahead of time, beautiful thing. If you multiply all 3 of those together, which will take a little time tonight. I love what he said. It will not take us here. It will not take us to x cubed minus 8. Darn it. I love the way you were thinking. That's exactly what I was thinking, sitting there looking at it for the first time. It won't work. Does anyone have another idea? Searching my students to see if someone remembers it. It's one that my colleagues who are teaching calculus, they get so angry. They say, Ranger, you didn't show me math 2 how to do this? I showed them, yeah. They may have forgotten. Does anyone remember how to factor x cubed, that's a cube, minus 8? That's the hardest one on the board. First, a student may recall if I do this. It fits a particular formula. The formula looks like this. A cubed subtract b cubed. That's what this one's going to take the formula out. A cubed minus b cubed. It's called a difference of cubes. Not a difference of squares this time. A difference of cubes, which is harder than a difference of squares. Does anyone recall anything at all about a cubed minus b cubed category difference of cubes? If so, we can get this to work out. Oh, I see a hand going up. Help me.
Some kind of inverse?
Come again.
Some kind of inverse?
Not inverse. Now I'll give you a start of what I need. It's like a formula. Part of the formula is this. This may bring back some memories. That's the first part. Required. This is the hardest one. Now, if anyone can tell me the last part, which is will be a trinomial, we'll have it. But you're going to start out with a subtract b. By the way, guys, in my case, a is, what's being cubed here? X. That's my a. What do you think the b is? What's being cubed to give you an 8? 2. So I know the a and the b, so you say, Professor, if you're going to eventually give me the formula, which I will, the first part really says x subtract 2. It starts out with x subtract 2, a minus b. But the next part is the hardest part to finish it up. Does anyone recall it all? Well, I'll just go ahead and give it to you. It's the formula. Next, a squared plus ab plus b squared. That's the toughest one because you have to recall the formula. Now, if I apply that formula on my x cubed minus 8, then check it. Let's hope it works. Anna, I know during winter you said you have saw something like this in your math 8, I think, class, some in a math 8 problem. Where in math 8, they just assume you know how to do it. They're doing calculus in math 8. So if you run into this in math 8, they're going to say, no, don't worry about that. You should know that. I'm doing some calculus on the instructor will say, I'm doing some calculus on this. You should know this ahead of time. Ramsey should show you that. So by formula, that's the way it looks. Now, if I apply the formula, and you guys have already said x and 2 are the a and the b. So this is the a, this is the b. I'm going to just fill in my formula. Now, a squared would look like what if a is representing x? Is that x squared? The product in my formula, if I accept the formula as a times b, what would a times b look like if a is x and b is 2? 2x. And finally, b squared. B is what, 2? 2 squared is 4. Now, my student over the side here, who says x minus 2 times x minus 2 times x minus 2, I said, oh my goodness, sorta? I know what he's thinking of, sorta? Close? Who on earth would think, Professor, are you sure? Professor, if you multiply this mess out, you're going to get the black? You're going to get the x cubed minus 8? You will. I will check it. It looks so strange. Who on earth would think that that green is the same as the black? Except that now it's in factored form. So guys, I'm going to check the green over here. Can anyone tell me if this is true? Now I use the formula now. It's all a formula for a, and they call this a difference of cubes. Let's get this out of the way tonight. Can anyone tell me how would I check to see if that green really works? Not to multiply it out. If I walk across the street and ask those kids across the street to multiply that out, I think they could do it. How would you do it? How would you multiply the green out to see, Professor? It gives you the black. It's going to give you x cubed minus 8 if you clean up the green. Okay, can anyone suggest to me how would you start the green? Here's the green. I'd like to multiply it out. And hope it gives me this. And therefore the two sides are the same. Who has an idea? We're going to use the distributive property. How many times? Twice. Well, first take x and use a distributive on all three of those terms. I'm going to take x on each one of those. X times x squared is x cubed. Now help me out here. X times 2x is 2x squared. X times 4 on the end is 4x. There's each one of those terms on the right here, with x used as a product. X cubed plus 2x squared plus 4x. Am I finished with the distributive property or not? No. What else am I supposed to do? I'm supposed to now use the distributive property with -2 on each one of those. Now help me out. What's -2 times x squared? -2x squared. Look where it goes. -2 times 2x, -4x. Look where it goes. And finally, -2 times +4, -8. I use the distributive property twice. Combine like terms, aren't we lucky? Does that take me right to that? Is that the same as x cubed minus 8? Who out there thinks that's the same as x cubed minus 8? That green is the same as x cubed minus 8, and we just confirmed it is. Or we use something called a difference of cubes formula. And it checked. Just step back and look at it. I don't know how many students that would recall a difference of cubes formula. I'm sure somewhere in your math you probably have seen it somewhere. Okay? Now, with those little techniques of factoring, I think now, let's see if I'm ready to see really where we're going. Yes, I am. Here we go. Now, guys, with all that said, here we go. Part 2. Let's jump into where we should be. Solve. I'm going to start out with that. I'm embarrassed. I'm going to start up with that. I want you to solve for x. Listen, really, Professor, 4x subtract what? Was it 10? It's equal to 2? I know right now, Professor, you're going to eventually move that over by adding. And you're going to end up with 4x is equal to what? 12? And then divide by 4. X is 3. And you're finished. And you're hoping next Wednesday I have a lot of these types. Aren't you? You're hoping when you open your quiz next Wednesday for your first 10-point quiz that I have lots of those just like that. Just move something over, then divide by something, and you got the answer. Next one. Okay, the same color as I keep this. One, part B. Next one I have looks like this. Now get ready, because I need some input here shortly. Beautiful. -2 times x subtract 4 plus 6 is equal to a -8. Can anyone give me a start on that? And it's not going to be too bad. What would you suggest I do first? Try and solve for x. Can I use the distributive property out front? What was that? -2 there? Oh, you got the answer already?
Yeah.
Oh, okay. She thinks she has the answer already. Let's go through the process though. If I use the distributive property right here, distribute the -2. That's a -2x plus 8. That's done. Still got plus 6 out here. It's equal to 8. collect like terms on the left. I could rewrite the left-hand side as 14. 8 plus 6 equals 8.
Sorry, I'll think about it.
Is that true? So far, so good? Next step would be, what would you do next? Well, subtract 14, move that over, so you end up with a negative 2x is equal to, guys, if I move that over, 8 subtract 14, what is that, negative 6? Watch my math here.
Tree.
Divide by negative 2. You say, Professor, really, all that just to get you into a positive 3. For an answer.
Mr. Ridley?
Is that correct? Because I'm going to check and see if that's what I want. Did we do it correctly? Okay, go back and check, guys. Let's see what we did. Did someone see something maybe that it's not working out? I didn't check the answer. I should take that right back and check it right quickly, but some students have their hands up like, Professor, you're going to set us up. I sort of have a feeling. What do you think?
Perhaps keep your 8 negative throughout the equation.
Oh, right here, see, this is what students do on the quiz. He says, Professor, hold on. I get so excited about doing my math, Professor, I forgot that was a negative 8. And negative 8. I've seen students do this. Now, when I move that 14 over, what is that? Negative 8 subtract 14? That's going to change things altogether into what? Negative 22, is it? Is that true now? It changed altogether. Then divide by what? Negative 2 here. Does the answer now fall into, looks like 11? Is that true? And then when I'm scoring papers, all of a sudden I saw that first answer and I'll say, well, yeah, it's my job to go back and see, where did you mess up? You dropped that negative sign for some reason. You got all involved with the process and you forgot that it was a negative 8, and that threw everything off. Now, does it look good with 11 now, working out? Okay, so some equations there to look at. Part C. Next one looks like this, and then we'll go from there. Beautiful. Hang on. Oh, on the handout. That's what I had reference to. Next one looks like this. Square root m minus 1 equals m subtract 7. Solve for m. Now notice how all these equations are all mixed up. Any suggestion here? What on earth would you do algebraically? I don't want to just sit here and guess at the answer. What might you do to show some algebra behind it and try to solve this thing? Yeah.
Algebra squares.
Okay, if she wants me to do this, square both sides. To eliminate that square root. As long as I do it to both sides. The left-hand side is going to be nice. Square root drops off. Right-hand side, I guess when I square the right-hand side, can someone tell me on the right-hand side, which I must square, what is m subtract 7 squared? Is it m squared plus 49? That's what I've seen a lot of in the past, and it's not. It's a little bit more. Who has an idea? What is m minus 7 times m minus 7 will give me? Besides m squared plus 49. Yes?
What is the m squared minus 14x
Plus 49.
14.
Look at that. If you set down m minus 7 twice, m minus 7 times m minus 7, and some of you guys use that word FOIL or distributive property or expand it out, he's telling me you end up with m squared minus 14m plus 49 when you multiply it out. Now we got an issue. We've done what you guys suggested. I don't have the answer yet. Now let's call that step 1. We squared both sides. It's beautiful. Now what? What would you suggest I do now? And let's see how all this math I'm talking about right now ties in. What would I do now? Any ideas? Yes? All right, you want me to move something over? You want me to move some terms over? I could move this m over if you wish. That might do something for me,
Well, we can factor.
right? Could I move it over? And then I think he wants me to move maybe also, hang on. Could I move this -1 over to join the 49? I can do that, if it'll help. By the way, would that leave 0 on the left-hand side? Everything being moved over? Now, if I move it over, I got 0 here. Now, if I do move over, I still got m squared. Guys, how many m's will I end up with? I got -14, and I'm gonna try to move that over by adding 1. Is that gonna be a -15 or a minus, what is it? -13, what is it? What do you guys think it is? Or is it gonna work out at all? Is it -13? Or is it -15? Jeez. Okay, well, add what? Move this over. Am I adding 1? 1 m? Or am I subtracting m? I've seen students do that. So you're saying to move that over, Professor, come on now. You're going to subtract m to make those cancel. So I'm going to end up with, I think I heard -15 m put together. Now, the suggestion was also to get rid of that 1, that -1. I'm moving it over by adding, I guess, adding 1. So if I add 1, what will I end up with when I move it over and add 1 to 49? 50. Well, that's cute. I don't have the answers. By the way, I'm expecting 2 answers. This is known as a quadratic. I'm expecting 2 answers. Where should I go now? Where should I go now? I have to go back to this. I gotta go back to this. Can I factor that? Can I do what I was doing over here? That's how these two are connected. Can I now say, Professor, the best I can do is, I hope, maybe it will work. Can I do this?
With 5 and 10.
Does anyone have an idea of what, and we're doing a few of these over here, where we had to do like a trial, we tried something, see if it worked. If it didn't work, we changed things. Guys, if it factors, it may not factor. Definitely it's gonna be an m here and an m here. Now, see, you have 50 stuck on the end, fairly large number. What are some choices for 50? 10 and 5.
-10 and -5.
Oh my goodness, you said -10 and a -5 right quickly. Hang on. That is a positive 50, which I want on the end. But the big check here was, like we did one back here, these two, or a product, is a -5 m. These two, a -10 m. Will those two put together? If not, we got issues. Will those put together give me that middle term? If not, we can't use it. Will -10 and a -5 put together give me the -15 m that I want in the middle? It does, so that means you're good. We don't have the answers yet, but it has been factored correctly. Now, what are the answers? There's something called a zero product property. That's why that 0 is critical. If that is set equal to 0, which it is, you're allowed to do this. Split these up and set each factor equals 0. One of the easiest strategies ever, and merely solve for m. Solve for m. I have 2 answers. 10 and 5. I'm not going to check these tonight, guys, for the lack of time here, but back up here, I think 10 and 5. Now, I said for the lack of time. Let me go back real quickly. I'm not going to do a full check. I'm going to ask you. The original equation that I was trying to solve looked like that. She suggested square both sides. Let's check 10 right quickly, just out of curiosity. 10 subtract 1 gives me what, 9? Square root 9 is what? 3. On the other side, 10 subtract 7 is 3. Do the 2 sides match up? And a smile comes on your face next Wednesday. 10 works. I've seen some of these where you get answers. I should call them answers. You get possibilities, and nothing works. At least 10 works. 5, I'm right. 5 subtract 1, 4, square root 4 is 2. 5 subtract 7? -2. Did I do that correctly? If I replace by 5, would this be square root 4, which is 2? Just 2. And over here, 5 subtract 7 is what? -2. Do the two sides match up? No. Therefore, this has to be rejected. There's only one answer. In this case, m is equal to, after all that, look at this back up here. I gotta mark that out. 10's the only one that worked. And I've seen some of these where you check both and none works in this little process here. Now, before I jump into, and we've got some time here, thank goodness. Why, Professor, must I really take the time? And on your quiz next week, if you have one of these with a square root, I'll probably on the side say, check your answers. Because one of these answers may not work. Who knows? Most of them may not work. Why is that a possibility, especially on the square roots? Look at this. If I ask you, or ask an elementary school student, is that a true statement? Is -3 equal to a +3? You would quickly say, no, that's impossible. But if I do what she suggested I do on the quiz, on the problem there, let me show up on the quiz, she suggested, Professor, on the very first step, we squared both sides, didn't we? Now, does this now become a true statement? That's the difficulty. When you square both sides of an equation, it may now become true. 9's equal to 9. When in the original, it was not true. So that's why you must check these answers to see if this craziness is happening. And will both these answers check? So there must be a check required here on one like this with the square root. And I'll warn you, check it. Guys, letter D. Now, get down to right where I should be. I'm looking at this. And this is, it certainly is. X squared, subtract 2x, subtract 1 is equal to 0. Another so-called, let me use that word right now, quadratic. I need that word now, quadratic. Highest exponents of 2, known as a quadratic. Now, what does that look like if I say, now, solve this one? What might you attempt to do on this one? I might think as a student, Professor, do the same thing you were doing over here. Factor. Set it up and try to factor this. That's what you have been doing. And do this. This is like a trinomial. We talked about that over there. And if I try, maybe an x with an x, now what are you going to try to get the -1 on the end? What are you going to place on the end? To hopefully get -1. What are some possibilities? Not many. You can place -1 here, and a +1 here, that's a -1. Do you think now, placing those the way they look, if I should now multiply this out, guys, will that take me back to the original purple? If I multiply these two together, it's not going to. Because the professor changes signs. Make this the plus and this the minus. Even if you change the signs, what's going to happen? There's a -1x. Here inside is 1x. What happens to the x's? Will they cancel? Is that going to ever take me back to the purple? You can sit there all day and try to factor like we were factoring over there. Try, keep putting numbers in, change them around, check, 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 check. All day, nothing works. Now, we've done such a beautiful job tonight. Can anyone tell me what is out there for us in math that if I run into a quadratic, it's got to be a quadratic, and the darn thing will not factor? What was it that you as a student always had to rely upon that you could turn to and get the two answers that are guaranteed here, those two answers, but you can't use factoring to get the two answers? What else could you turn to? And I saw a hand going up. Yes? Something called quadratic formula. And if there's one thing students love, it's the quadratic formula. All students do. What does it look like? You may not have seen it in a while, x is equal to negative b plus minus square root b squared, subtract 4ac all over 2a. I wrote down quickly, did I write down correctly? For you guys who recall, is it negative b plus minus square root b squared minus 4ac all over 2a? Apply that quadratic formula and we hope we can get an answer. Now if I jump in and apply the a, b, and c and review this with you, Professor, could I have used this quadratic formula on, where am I? On this quadratic over here? You could have. As long as it's a quadratic, you can use quadratic formula on all of them. You don't have to sit there and try to factor like I did this one. You can apply the quadratic formula unless you're required to show factoring. So guys, on this one, the a, b, and c, what are they talking about here? The a is my leading coefficient. Let me write it like this. For a quadratic. A is my leading coefficient. Understood to be a 1 here. A is 1, B is negative 2, and C is negative 1. Let's have to identify the numbers for the A, B, and C. And carefully take them into the formula, replace them, and what's going to happen? Well, put it in here. X is equal to, I got negative, and then I got to put the B in. Well, B up there is negative 2. If I have it marked correctly here. Close that up. I'll be cautious here. Then it says plus minus square root b squared. There comes b again. B has been identified as negative 2. Of course, it's being squared. Subtract 4 times a. A is understood to be a 1. No problem. C has been identified as, what was that up there? Negative 1. Go ahead and write down. And all that's over, there's no mistake, 2 times a, 2 times understood to be a 1. If I put the numbers in correctly. Did I put them in correctly? I hope. The a, b, and c. Now let's calculate what this looks like. Guys, as I do my calculation, out front here, of course, is going to be a positive 2. Do not make a mistake. I'm right on top of the board here looking over. Positive 2 plus minus square root. Now, underneath that square root is where most students make a mistake. Got to be very careful. The first part, no problem. That negative 2 squared is 4. No problem there. I would suggest, to maybe avoid mistakes, you have this much more remaining underneath there. What is that? It's like a negative 4 times 1 times negative 1 remaining. What's that product altogether? Is that going to turn into a positive 4? A negative 4 times 1 times a negative 1, those 3 remaining numbers, multiply those together, turns into a positive 4. And then all that's over 2 times 1, there's no doubt 2 times 1 down here is 2. And I have that. If I put it in correctly. Now we have this, 2 plus minus, guys, all together underneath there is 8. All over 2. Now, is that correct so far? Now, what's the problem? And by the way, check my signs. Are my signs all correct? Does the arithmetic make sense? Okay. What's the issue? Well, it's square root 8. It's not square root 16. It's square root 8. It's not square root 25. Can I still deal with it? In other words, I came up with something that's not a perfect square root. Can anyone tell me what would you do if possible? It's not perfect. To break this down somewhat, if possible, for that square root 8. Who recalls? It's not perfect. I wish it were a 16 or a 25 or 100. It's not. It's 8. What does it look like if possible? Any ideas? And it will simplify. It's not going to be nice, but it will simplify somewhat. I could rewrite that square root 8, if you wish, like that. 4 times 2. Now, do I now have a perfect one in there? Yeah, square root 4 is what? 2. So I can call this 2 with a square root 2 remaining, and bring that down here. Where was I when I was doing all my work here? 2 plus or minus square root 8 right here as 2 root 2 all over 2. So square root 8 now can be written as 2 root 2. Not perfect. Now, can I do something else to simplify this before I leave it? I see something else on the end here that we wish to do to make the answer more simple. Simplify it. What is that? Look at all these. What do you think I can do with all those 2's floating around? Just simplify the answer and make it look a little better. And in fact, does anyone have an answer as to what may look like simplified? I may take a point off if you do not simplify this into its most simple form. Can I do that? All those circle numbers, could they be divided by 2? Reduced down by 2? In other words, divide by 2? Out front, 2 divided by 2 is 1. This 2 divided by 2 is 1. So put a 1 there with your root. And of course, the bottom part is 1. Understood to be a 1. So now I have the answers in simplified version as those. And are there 2 answers there? Yes, a 1 plus and a 1 minus. So I got 2 answers there for the quadratic. Jeez. Now, the first day when we do all this, and we're getting it done, this is pre-calculus. What am I doing right now the first day? Algebra. I'm doing more pre-algebra the first day. And we usually start out, I do, in my classes, I usually start out with that. Could I have jumped into something in chapter 2 real quickly and say, let's do this? No way. Because some of my students, I don't know you yet, I'll get to know you. Some of my students seated here tonight may have not had a math class in 5 or 6 years. Or when they did have a math class, back in high school, well, I know how high school is, just smile as a teacher and you got the A. Yeah, remember those days? I used to supervise student teachers in high school. I'd walk into a class, I'd sit in the back to watch the student who planned to be a teacher. I had to supervise that teacher. I'd walk in the classroom, I said, my goodness, this is such a nice classroom, and this is such a nice school. Everyone's smiling and enjoying school so much. This is a joy to come to school. It's a joy. And I talked to my student teacher, and 90% of her classes or students were failing. Oh, you got a smile on your face if you're failing. But everyone was happy. But they weren't doing what they were supposed to be doing. Okay, guys, we're doing this. Okay, now most of this is algebra. Some of you guys recognize this. It will come back to all of us eventually. Now, it's going to really take off. Not so much tonight, but next week. Now, what I want you to do on that handout, guys, I think you got to have a blank. If you flip it over, I think the other side's nice and clean, isn't it? Nothing there? I want you to try something for me. Now I need you to sort of walk around Anna. I want you to sort of walk around also. I want to see, because I need to get to know my students. Here goes. Am I ready? Yes, I think I am. I'm going to place one.